Okay, so we're going to take the derivative of the inverse tangent function. Y equals arctan x. First step is going to be take the tangent of both sides. So we have tangent of y equals tangent of arctangent of x. And the tangent of arctangent of x is just going to be equal to x because tangent and arctangent are inverse functions and they're going to cancel each other out. So we have tangent of y equals x. Next step is we're going to take the derivative with respect to x of both sides of the equation. So here we have derivative with respect to x of tangent of y. So we're going to have to use chain rule there because we can't directly take the derivative of a function in terms of y with respect to x. On the right hand side we're going to have derivative with respect to x of x, which is just going to be equal to 1. So we have chain rule here, we have dy dx times d dy of, let's move down a little bit, of tangent y. Now the derivative of tangent y with respect to y is just going to be secant squared. So we have times secant squared y equals 1. And if we go up top, we can see that we have a function of y equals arctan x. The derivative of y with respect to x is going to be equal to dy dx. So we can go ahead and solve for dy dx. dy dx equals 1 over secant squared y. Now we're at a bit of an impasse because secant squared y is in terms of y, but the inputs we have are generally going to be in terms of x. So we're going to want to rewrite this so that we have the derivative of y with respect to x in terms of a function of x. So let's use one of the trigonometric identities from up top to rewrite that. So we have a line here, tangent y equals x, that we can use. Tangent of y is equal to x. And since the definition of tangent is the opposite over adjacent side of a right triangle, we can say the following. We have a tangent of angle y equals x. The opposite side can just be treated as 1. So we have opposite side equal to x. And then we can have an adjacent side equal to 1. And so the tangent, the opposite over adjacent, is going to be equal to x. So that satisfies this. Now we can find the final side by using the Pythagorean theorem. So we have opposite squared plus adjacent squared equals hypotenuse squared. We have opposite, which is x, so we have x squared, plus we have adjacent, which is 1, so we have 1 squared, equals hypotenuse. Now, 1 squared is obviously just going to be equal to 1, hypotenuse squared. So we can rewrite this as hypotenuse, taking the square root of both sides. Hypotenuse is going to be equal to the square root of x squared plus 1. So we have up here x squared plus 1, take the square root of that. And this is actually going to be an absolute value because when we're dealing with a reference triangle, The adjacent side is actually in the I direction. It's a vector in the I direction, and the opposite side is going to be a vector in the j direction. So these two parts both have direction and distance. The opposite and the adjacent side both have direction and distance. The hypotenuse is just the distance between the origin and the endpoints of that vector addition, which means there is no direction for that hypotenuse. It is just a raw distance. The direction is actually given using the y value here, but as it is written as a hypotenuse, it's just a scalar distance. So that's always going to be positive, because there's no such thing as a negative distance. There's such a thing as moving in a negative direction, but there is not a negative. You can walk a mile in the negative x direction, but you can't walk a negative mile. So in this particular case, it doesn't matter, because x squared plus 1 will always be positive. A negative squared will be positive plus 1 is a positive, and a positive squared is a positive, plus 1 is a positive. So in this case, we can actually omit. People tend to omit the absolute value signs, but it's going to be important that we keep that in mind as we continue working with trigonometric functions. So we're solving for secant. So secant equals hypotenuse over adjacent. Secant of y is equal to, the hypotenuse is, like I said, we can get rid of that absolute value in this case, because it's always, this function is always going to be positive. And then the adjacent side is just going to be equal to 1. So secant of y is going to be equal to the square root of x squared plus 1. Now we can use this function here, which is equal to secant of y, to replace this and put it in terms of x. So we can have dy dx equals 1 over secant y is equal to the square root of x squared plus 1. And then since it's secant squared y, we're going to go ahead and square that. So then the final step we have is to say dy dx is equal to 1 over x squared plus 1, because the square root and the squared cancel each other out, and we are done.